In this example, I need to solve the following equation on the interval 0 to 2 pi. The equation is the sine of x plus the cosine of x equals -1. What type of equation is this? There are trig functions present, so it's a trigonometric equation. How many trig functions are there? Well, I have the sine of x and the cosine of x. And what is the degree on each of these functions? Each of these terms is just raised to the first power, so I have a linear trigonometric equation involving two different trig functions. Initially, this looks like a fairly simple trig equation, but in fact it's one of the more complicated ones to solve. Because what we want to do is write this trig equation in terms of just one trig function. And there's no easy way to write cosine x in terms of sine x or sine x in terms of cosine x. However, using a Pythagorean identity, it's easy to write cosine squared x in terms of sine squared x or sine squared x in terms of cosine squared x. So somehow we're going to have to square things so I can use that Pythagorean identity. So here are the steps for solving this type of equation where there are two different linear trig functions that are not reciprocal functions. Are these two reciprocal functions? No. The way we solve these equations, step 1, we isolate one of the trig functions on one side of the equation. Then we square both sides of the equation. Step 3, we use the Pythagorean identity to write the equation in terms of only one trig function. Then we solve the resulting quadratic equation in one trig function. And then finally, we must check for extraneous solutions. So looking at our equation, here's my equation. I need to isolate one of the trig functions. Does it matter which? No. I'm just going to subtract cosine x from both sides of the equation. And so I get sine x that is isolated equals -1 minus cosine x. So that's step 1 done. Step 2 says to square both sides. So I'm going to square the sine of x and square the right-hand side. So what is sine of x all squared? That's just sine squared x equals. I'm going to do this the long way, but there is a shorter way I'll talk about in a minute. So this is just -1 minus cosine x times -1 minus cosine x. And I'm going to FOIL it out. -1 times -1 is 1. -1 times negative cosine x is positive cosine x. Inner negative cosine x times -1 is positive cosine x. And last, negative cosine x times negative cosine x is positive cosine squared x. Collecting up like terms, I have sine squared x equals 1 plus cosine x plus cosine x is 2 cosine x plus cosine squared x. Now remember, that was the longer method for squaring this binomial. The shortcut method says you take the first term and square it. -1 all squared is 1. Then you take twice the product. So 2 times -1 is -2. -2 times negative cosine x is positive 2 cosine x. And then square the last term. Negative cosine x all squared is cosine squared x. It doesn't matter which method you used to square that binomial. So now I've finished step 2. And to do step 3, we need to go on to the next slide. This is where I got to on the previous slide. So we need to use a Pythagorean identity to write the equation in terms of only one trig function. So I need to use the useful Pythagorean identity sine squared x plus cosine squared x equals 1. Now, as my equation has a cosine x and a cosine squared x, I need to write the sine squared x in terms of cosine squared x. So I know that sine squared x equals, subtract cosine squared x from both sides, I get 1 minus cosine squared x. So instead of sine squared x, I'm going to have 1 minus cosine squared x equals 1 plus 2 cosine x plus cosine squared x. So now this is a quadratic equation. I want everything on one side, 0 on the other. So I'm going to subtract 1 from both sides and add cosine squared x to both sides. So on the left-hand side, I'm just going to get 0 equals 1 minus 1 is also 0. So I'm going to get 2 cosine x plus cosine squared x plus cosine squared x is 2 cosine squared x. So I have a quadratic equation. I have 0 on one side. Is there a common factor on the right? Yes. I can factor out 2 cosine x. And if I factor 2 cosine x out of 2 cosine x, it leaves 1 as a placeholder. Plus, and if I factor 2 cosine x out of 2 cosine squared x, it's going to leave cosine x. 2 factors multiplied together equals 0. Set each of them equal to 0. 2 cosine x equals 0. Divide both sides by 2. I get cosine x equals 0 over 2 is 0, or 1 plus cosine x equals 0. Subtract 1 from both sides, cosine x equals -1. I'm going to need some more room, so going on to the next page, here are the 2 solutions I got from the previous page, and I put my unit circle here. And remember, the cosine of x is the x-coordinate of all my ordered pairs on the unit circle. So where is the x-coordinate equal to 0? There is one value right here. So x is equal to pi over 2. And the x-coordinate is also equal to 0 right here when x equals 3 pi over 2. And when is the cosine of x equal to -1? Well, the only place where the x-coordinate is equal to -1 is right here, and that is when x equals pi. So these are 3 potential solutions, but don't forget, since I squared both sides, you must check for extraneous solutions. So let's check our first one of x equals pi over 2. That means I plug it back into the original equation over here. So I have the sine of pi over 2 plus the cosine of pi over 2. Does it equal -1? Here's pi over 2. The sine of pi over 2 is the y-coordinate of 1. Does 1 plus the cosine of pi over 2, that's the x-coordinate, is 0. Does 1 plus 0 equal -1? That is definitely false. So that is an extraneous solution. Now let's check our next solution. Let's check when x equals 3 pi over 2. I need to see if the sine of 3 pi over 2 plus the cosine of 3 pi over 2 equals negative 1. 3 pi over 2 is down here. The sine of 3 pi over 2 is negative 1, plus the cosine is 0. Does negative 1 plus 0 equal negative 1? Yes. So 3 pi over 2 is a good solution. And lastly, we need to check our final solution we found of x equals pi. Does the sine of pi plus the cosine of pi, does that equal negative 1? Sorry, I'm running out of room. The sine of pi, here's pi. The sine of pi is the y-coordinate here of 0. Does 0 plus the cosine of pi is the x-coordinate of negative 1. Does 0 plus negative 1 equal negative 1? That is a true statement. So x equals pi is also a good solution. So this equation has two solutions, x equals pi and x equals 3 pi over 2.